getting a picture on the TV. Okay, got a good picture, huh? There's a great deal of contrast that, and currently it's upside down on monitor, but we can make out a fair amount of detail. Okay, we can verify the position, the opening I ought to have on the camera. Okay, I just checked, getting back up to that first step. Not if it's collapsed too far, but it's adequate to get back up. This is Houston, F2, I'm at just 1/160th second. Okay. I'm at the foot of the ladder. The lamp footbeds are only depressed in the surface about very fine grain as you get close to it. It's almost like a powder. Down there, it's very fine. I'm going to step off the lamp now. It's one small step for man, one giant leap for mankind. Not even collapsed too far, but it's adequate to get back up. Do we copy? Pretty good total count. At the foot of the ladder, the lamp footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine grained as you get close to it. It's It's one small step for man, one giant leap for mankind.
Bon dia, everyone. My name is Richard Weiss. I'm the president of the Explorers Club, and I'd like to welcome everyone to the first Global Exploration Summit, or we like to call is GLEX. You just heard Julian Resende play Let's Go to the Moon Again, and what an appropriate song that was, considering it's been 50 years since we first went to the moon. For all of you who know the Explorers Club, you know we're a club of the impossible. This is what we do. But before I tell you our story, I'd like to tell you another story. This is a story about a man who walked on water. He wasn't from Nazareth. He was rather a man who walked on water in Nazaré, which our Portuguese know is just up to the north. I'd like to introduce you to and acknowledge the first man to surf a 100-foot wave, Hugo Val. Hugo, please stand up. Hugo just spent the last 4 days surfing with myself and my kids, and we surfed 2-foot waves. So if you average his tallest wave and our tallest wave, you know, our group surfed over 50 feet, so I'm very proud of that. So Hugo, thank you very much for being so humbled to surf such small waves with my family. But that's, I think, part of the humility that you find throughout Portugal. All right, now to the story of the Explorers Club, for some of you who may not know. The Explorers Club was founded 115 years ago by the first people trying to go to the North Pole. But probably the best way to explain our story is to take you back to March, to our annual dinner. We had 1,700 people in New York City, and I asked some simple questions. I think for explorers, they know these are simple questions. And if anybody wants to raise their hand during this questioning, please go ahead. Who here has been to the North Pole? We had about 250 people in that audience raise their hand. Who's been to the South Pole? Whoa, this is actually almost as much as we had there. We had 200 people. Then I asked the question, who had been on top of Mount Everest? And we had, we have a hand over here. Any other hands for Everest there? We had Sir Edmund Hillary, obviously, The first person on Everest is one of our members. We had about 24 people, including a Sherpa woman who had climbed it 9 times, more than any other woman in the world. Then I said, who here has been to the Marianas Trench? This is the deepest point in the ocean. Now, unfortunately, in March, people were busy going to the Marianas Trench, but anybody here, there's only been 4 people to do it. Anybody here been to the Marianas Trench? We have 2 people. Don Walsh, the first person here who did it in 1960, so very historic thing. So I wanted to challenge our audience a little more. And I said, who's been to outer space? And so we had, anybody here from outer space? Oh, there we go. Another, you know, the Explorers Club, you throw down these gauntlets and people are like, yeah, a couple times. In fact, one of the best stories I ever heard, you know, usually explorers like telling stories, and there was this guy, Chris Hadfield, is a Canadian shuttle astronaut. Any Canadians here? Okay. Oh, yeah, George, okay. So we're talking about the aurora borealis, the northern lights, and, you know, I'm saying, yeah, I got this shot, 45 minutes, I sat there, the lights were going, and he said, I did a spacewalk over my country during a full-blown aurora borealis. How do you beat that story? Well, I'll tell you how you beat that story. So you had the 30 or so people who raised their hand. And I said, let's take it out a little further. And I said, who here has been to the moon? And we had 6 people raise their hands. And that was a pretty cool thing. And then I said, let's take it even a little further. And I said, has anybody sent a spacecraft out of our solar system? And of course, we had Alan Stern do that. So the Explorers Club, you throw down challenges. We are about the impossible. So why Portugal? Why is Portugal here for the first Global Exploration Summit? You know, the obvious is Magellan. Magellan was born here, and then Magellan and Elcano did the first circumnavigation. They started the first circumnavigation of the Earth with the Spanish 500 years ago. But I think that that's the past, and I think of Portugal as a country that sits on the Atlantic Ocean and looks forward. You know, if you know anything about sustainability, Portugal is a leader in sustainability. But I think perhaps what will end up being the key trademark or aspect of Portugal that people will recognize, fall in love with, and want to be part of is the whole idea of inclusivity. Portugal is one of the most welcoming countries on earth to all cultures, whether you're a refugee, whether you're white, black, green. I think maybe aliens will land here first because it's so welcoming. So I applaud the nation of Portugal for that inclusivity. It is something that we all should work towards. Because after all, we know there's problems on Earth. We're not about the problems here. We're about solutions. And in order to have those solutions work, we all have to be working together. All nations, all sexes, everything working together. So I would like to applaud the nation of Portugal for that inclusivity. And, you know, my first sort of entree onto the warmth and humility and all the great things of Portugal was through the Secretary of State of Tourism, the Honorable Ana Mendes Godinho. So, Ana, please stand. You're responsible for this. I know you're very modest. She's standing in there in the front shaking her hands. Ana, thank you so much. You know and I know how much you're responsible for making this happen. Thank you, Ana. Now I'd like to introduce the Minister of Science and Technology and Higher Education, the Honorable Manuel Heitor.
Thank you very much and welcome you all to Lisbon and Portugal. Also, a special thank to Ana Mendes Godinho for organizing all this event with her team. I'll be very brief and particularly inspired by the music we heard from Júlio Rezende. Actually, I'm not supposed to introduce himself, but it was inspired because he's a well-known jazz pianist which has done a lot of experimentation. And actually, over the last years, he has combined jazz with traditional Portuguese fado music, and this disc, which he presented here today, also combines jazz with rap. Actually, this is an important symbol of Portugal in modern times, a country of experimentation, a country that looks forward new horizons of knowledge, but also in a way that we know that experimentation needs to be combined with a solid knowledge base. Actually, Julio has a background on philosophy and also the multicultural and multidisciplinary framework that we find in the young generations, essentially combining the traditional the disciplines with new frontiers of interdisciplinary knowledge, is the environment that we want to provide and the trust building we want to foster to young generations to find in Portugal a friendly environment for innovation, certainly with a solid scientific base, but also looking at the future. 500 years ago, when explorers, and particularly Fernando Magalhães, toured around the world, experimentation was the main driver. Risk-taking was particularly important, but certainly in a stepwise approach by developing a solid knowledge base, which we today clearly understand that took years to go, and certainly it was very uneven distributed throughout the world. In our last decades, we have essentially centered our research and innovation context in building a solid knowledge base that we can certainly combine with our geographic position in Europe, but also in the borders of Atlantic, in a way that we can certainly promote the spirit of explorers with a solid knowledge base and certainly building and attracting people from all over the world through an innovation-friendly environment. Actually, the European Innovation Scoreboard, published by the European Commission about 1 week ago, completely shows Portugal in a different situation from some years ago, identifying in Portugal 3 major variables which certainly make us very proud, particularly for our global presence. First, Portugal is the region in Europe with the large fraction of innovators, particularly small and medium companies with a large fraction of new products and processes into the marketplace. Second, is one of the regions with the highest providers of what the Commission considers to be an environment friendly to innovation, and it has an attractive research system. And these 2 variables are more and more transforming Portugal. You may know, or you may not know, but you are in a country with world records of number of consecutive days fully powered by renewable energy sources. 4 days in 2016, 3 days in 2017, 3 days in 2018. And again, this was possible by a combination of exploring and experimenting new ways, particularly of energy storage, particularly using hydroelectric power and water dams to storage energy with aeolic and more solar energy, with the building up of a knowledge based on complex systems engineering to better articulate the complex dynamics of renewable energies with the electrical network. And again, step by step, by building that knowledge base, and again, by experiments, new ideas, we were able essentially to implement in this country one of the most reliable, sustainable energy networks, which actually today we use also to export energy and essentially to keep going into this field. Actually, tomorrow or after tomorrow, I'll be in the north inaugurating a large supercomputer that we have installed in Portugal. And again, our ambition is to have the largest computing facility at a world level, fully powered by sustainable energy sources. But essentially, if 500 years ago, we launched the tour around the world, 50 years ago, the man landed on the moon, and this ratio between 50 and 500, a ratio of 10, is exactly our ambition for the coming decade in terms of what we consider to be new space in an European landscape. We developed over the last years with many international partners a space strategy focused on new space and to promote breakthroughs also in the European landscape by developing a new legal regime for space launching activities and promoting a space agency in a modern way of promoting essentially new space oriented certainly for Earth observations, but particularly for mini and micro satellites. At the same time, we promote an innovative institutional context by developing what we consider to be, and later today will be presented, the Atlantic International Research Center, by combining research activities with innovation breakthroughs in North and South Atlantic, and particularly facilitating North-South, South-North interactions from the North Pole to Antarctica, but essentially under a global perspective to better achieve or to attempt better achieving a better compromise between economic development and environmental preservation, and that can only be achieved if we really innovate at an institutional level by building an international network with scientific and innovation activities. At the same time, over the last 2 years, we developed the Azores International Satellite Launch Program, and now we are putting together the final phase of a very ambitious program to launch from the Azores essentially mini and micro satellites within the European industrial landscape for payloads below 500 kilos, but in a way to really reduce the cost per kilo in orbit for orbits until 800 kilometers and guarantee essentially a number of launches per year, which will make new space sustainable also in the Atlantic and in the European landscape. And this has been done particularly under two major global processes. One, we developed what we consider to be Go Portugal, Global Science and Technology Partnerships Portugal, which we have been promoting either with leading North American universities. We developed the MIT Portugal program, the Carnegie Mellon, the Austin, the Harvard Medical School, also in Europe with the Fraunhofer Institute, and essentially opening up not only our research community, but our most innovative enterprise sector, essentially to global partnerships, again, making use of this idea that combining experimentation with a knowledge base needs to do towards an inclusive pattern of promoting innovation-friendly environment. Within Europe, we are more and more promoting what we call PERIN, Portugal in Europe Research and Innovation Network, which again is aimed to essentially foster more and more our presence in Europe and certainly the presence of European innovators in Portugal. During these 2 days, I'm sure that you have experienced many new ideas for exploring, essentially for building the necessary knowledge base to contribute for new explorations. I know that later today you listen to Zita Martins, one of our astrobiologists, that is also the commissioner of our annual Science Summit, which will be organized next week here in Lisbon. And again, I hope you enjoy a friendly environment to discuss, to build personal relations, but also to better understand the stepwise approach towards the future so that we can build better trust on our future generations, always with a better compromise between economic development and environmental preservation. Thank you very much for your participation.
Obrigado, Dr. Heitor. And you'll have to excuse me to my Portuguese friends if along the way some of the names don't sound quite the way you would say them. Someone once told me the sort of secret to life is knowing what you're not good at and then not doing it. So we're going to have a bunch of panels here. You're going to see some chairs being set up. So it's my pleasure now to introduce the first panel on exploration, past, present, and future, from Magellan to Mars. To moderate it, we're very fortunate to have with us the President of Tourism of Portugal, Dr. Luis Araujo. Dr. Araujo? Yes. Araujo. Okay, thank you.
Good morning. Good morning, everyone. It's a pleasure to be here. Welcome to Portugal and to Lisbon. It's a pleasure to see that 500 years later, we're still discussing the future in a place like Portugal, a country that is proud to welcome everyone, independently where they come from, and a country that is proud also to be a place for discussion of ideas, and especially preparing the future. So I'm going to call the members of my panel. The first one is Dr. João Paulo Oliveira Costa. He's a professor of history at the University of Lisbon and one of the world's leading experts on the age of exploration. The second one will be Mr. José Manuel Núñez de la Fuente, anthropologist and renowned Spanish historian of Magellan. And the third speaker will be Mr. Lawrence Bergreen, New York Times best-selling author of Over the Edge of the World, Magellan's Terrifying Circumnavigation of the Globe. Lawrence? And finally, to propel us to the future, Dr. James Garvin, NASA Chief Scientist of Goddard Space Flight Center. I think I was supposed to stay in one line, but I'm in the middle, okay. So, this is a challenge, especially for me. We're not going to talk about tourism, but we're going to talk about a very big trip, the biggest voyage of all times. So I'm going to start with João Paulo Oliveira Costa and give you the floor to tell us a little bit, to tell us more on the importance of the Portuguese world expansion and what this represented.
It's working? Yes. Good morning, everybody. Welcome to Lisbon. Welcome to Portugal. I expect to have my presentation now in order to start. Okay. So my talk will be about how Portugal was crucial for the beginning of this world where we are living today. We speak about globalization, and globalization started in a certain way here in Lisbon. So we are in the proper city as explorers to visit a city from where 600 years ago, 500 years ago, many people departed to explore the world. Why Portugal? Why was Portugal who started this a fantastic, amazing adventure of discoveries, of globalization. In a certain way, our geographic position is, of course, crucial. As you can see, we are in the extreme west of Europe, so we are peripheral to the continent. But if you look to the ocean, if you look to what is the coastal line of Europe, Portugal is not peripheral, it is central, because it gets together the Atlantic Ocean and Mediterranean. Actually, the city where we are now today, Lisbon, is where Mediterranean and Atlantic world meet, in the sense that the pictures I'm presenting here, if I would say that it was in Greece or in South Italy or South Spain, you could accept it. But these are in the oldest part of Lisbon, where streets have more than 1,000 years. Because this is the last, coming from south, this is the last Mediterranean-shaped neighborhoods, or the first if you are coming from north. So this connection between Mediterranean world and the Atlantic world, here in Lisbon, where there is an amazing port that can support many fleets at the same time, as it happened since the 15th century, or even since the 14th century, was one of the reasons why here was a good place to start. Why the importance? Why do we speak so much about discoveries? Because before, the world was separated in different areas that did not communicate among them. And here in Europe, the idea was, as told, for example, Saint Isidore of Seville, the ocean is incommensurable and uncrossable. That was the belief of all Europeans, even of people from the Mediterranean basin, including all the Arabic civilization of that time. So there was no knowledge, neither of the Atlantic nor of the Pacific Oceans. As you can see by the map that is on the right, the idea of the Europeans was an idea, imagine the sole ocean that was conceived and perceived was the Indian Ocean. Even there was no Atlantic, there was the waters, unknown waters, feared waters, but without the understanding of the shape of this ocean, which was here at our side. So it's important also to stress that Europe was a globalized area. Any invention that occurred in Scandinavia, in Russia, in Italy, in England, or here, it was in about 1-2 years was accepted and there was used by all the Europeans in a very quick moment. So it's important to stress that yes, Portugal was the country from where these adventures started, that Portugal has an individuality that helps that. For example, we have the oldest border of the world since 1297, is the same since then, the end of the 13th century. We are a country that is going to accomplish about 900 years of existence. And a country that by our position, central and peripheral at the same time, is also a country that is chosen by the Europeans as a whole, as a neutral one, as kind of sanctuary, as it happened during the Second World War. Portugal in the ocean and Switzerland in the interior are the two usual neutral countries that are sanctuaries for all those who are making war. And so that Portugal took profit from that, of course. But to say that this expansion that started in Portugal, this Magellan that we are going to speak about, this Magellan was Portuguese, he was also European, because it was all the European civilization that went out from here, with the printing texts, with the gunfires, with all the geographic knowledge, with the language that was not English at that time, it was Latin, that made possible that anybody, any people with knowledge, traveling from here to the north, to the east, or to the west, he could always find people with whom he could communicate. But it is always necessary to have a person that pushed people. And that person was the so famous Henry the Navigator. He did not sail, but it made people sailing. And so it was him, a prince of Portugal, that he lived from 1394 to 1460. And it was him who pushed his crews, his servants, to sail beyond Cape Bojador. Cape Bojador at that time was the limit of the known ocean. And it was supposed at that time to be impossible to sail further. Meaning that people was afraid of the boiling water, about monsters. And these that nowadays we look smiling to these images, at that time were not ideas, were not jokes. It was the reality in which they lived. The reality is that we not even imagine about space unless in scientific fiction movies. But actually, we don't expect to find monsters immediately. But here they were expecting to find monsters, and these small ships, despite could do the job. And what is important is that crossing of Cape Pujador in 1434 was a definitive victory over fear. Most of you are explorers. You dive, you climb mountains, you explore forests, whatever. You may be that sometimes you handed a mission because you had no conditions to go on, because of the material you had, because the conditions you faced. But for sure, you never started or never avoid to make a mission because you were afraid of a monster. At that time, they were afraid of monsters. And these people who made the first visit, they broke this fear. It was this European, Mediterranean fear about what was outside, and nevermore, for accomplish this mission, they took 13 attempts. But only one approached to the Cape, because all the others, because of the fear they had, they gave up first. And so that's why I don't know any other exploration that people gave up 12 times before they get it, and gave up not because it was impossible, not because it was much far than they expected, no, just because they were afraid of. And that's the great result, and that's the great contribution, is that capacity to make this in this sense. So then this new ship, the Caravela, and even this Caravela, despite to be used by the Portuguese, the first prototype was experienced in the lower countries, near to Brussels, because it was a joint venture between Portuguese and Flemish. Because, as I told you, these Portuguese discoveries, in a certain way, it was an European enterprise, performed first by the Portuguese, but by the others. Magellan, the crew of Magellan, they have people from different countries, not only Portuguese and Spaniards, but also Greeks, Italians, like Pigafetta, and others. So this sailing, the capacity to discover astronomical navigation, and then a new geography. That is main contribution. I usually, in my lessons, teach my students that these discoveries provoked a geographic revolution. This was the idea of the world by the Europeans at the beginning of discoveries, 1458. And then this is the Ptolemaic idea of the world so Ptolemy was a whole geographer from the Roman times. And as you can see there in the south, you can see that there was the vision of Ptolemy was that the Atlantic was not linked to the Indian Ocean, but then the discoveries obey the cartographer to make a connection, because the discoveries did it. And finally, in 1502, we have the first planisphere, and where we can see for the first time the shape of the Atlantic Ocean. So after this moment, the world became global. That map that we see here was possible due also particularly to this trip, the Cape route that was started finished by the first time in 1499 by Vasco da Gama. This Cape route allowed it that many goods from all Asia would arrive to Portugal. This picture here on the left is about porcelain that was found in a shipwreck in the mouth of the Tagus, here, 1 kilometer from here. We have several shipwrecks here in the Açores and in other parts of this Cape route, and all of them full of materials, not only from India, but from Africa and from all the parts of Asia, including China. That's why, nowadays, when we speak about these discoveries, I would like to stress that this is the map of the Chinese government about the belt of the Silk Road. But what the project I'm starting now is a project to emphasize how in reality this Silk Road, after the discoveries of the Portuguese, became had a new hedge in Lisbon actually, and we can find it by archaeology. So this, I would like that when you are here in Lisbon, you can imagine that you are in one of the limits, on the extremities of the Silk Road. Thank you so much.
Thank you, João. Thank you very much. People make the difference and drive humanity to overpass boundaries. And if there is a man or a person that did this, was Magellan, Fernando Magalhães. So to speak us about the man, I'm going to give the word to Mr. José Manuel Núñez de la Fuente to tell us a little bit more about Magellan.
I apologize, I speak in Spanish. My English is not so good than my colleagues. Hoy día, justamente, se cumplen 500 años de la primera vuelta al mundo. Magallanes y su tripulación lograron hacer esa extraordinaria proeza en poco menos 3 años. Hace 50 años, el hombre pisó por primera vez un astro exterior al planeta Tierra. Hoy día, la Estación Internacional Espacial invierte poco menos, unos 90 minutos para efectuar una órbita terrestre. Desde mi punto de vista, esas podrían ser simbólicas elipsis que la ciencia nos aporta a lo largo de estos 5 siglos. Hoy día nuestras sociedades tratan de explorar y descubrir nuevos horizontes, nuevos retos con los que enfrentarse al futuro más allá de las estrellas. Para ello, nuestros ojos y nuestro conocimiento se apresuran en investigar con instrumentos muy poderosos dónde está realmente el origen del universo, qué es lo que podemos realmente encontrar hoy día, cuáles son esos retos. Se da la paradoja que según los datos que nos aportan, por ejemplo, la sonda NAP, que ha tratado de estudiar el fondo radioeléctrico, digamos, los ecos del Big Bang, nos da una figura geométrica del universo que es absolutamente plano. Curiosamente, hubo un tiempo en que también la Tierra se aparecía para la ciencia y para las creencias de los pueblos como plana. Era, a pesar de las evidencias desde hacía milenios, con Eratóstenes, posteriormente Macrobius, Giordano Bruno, Galileo, hasta que finalmente apareció un hombre, Fernando de Magallanes, portugués, que se encargó de dinamitar todas esas creencias. Él se tuvo que enfrentar no solamente con unos océanos desconocidos, tempestades, motines de su tripulación, sino también con conflictos, intereses de las 2 potencias navales más superpoderosas de aquel tiempo, Castilla y Portugal. Realmente, a su tremendo valor, a su coraje y a su, digamos, férrea voluntad, él, sin embargo, añadió otra cosa mucho más importante, su fe en la ciencia, en el conocimiento, en las tecnologías. Solo de esa manera podría superar las barreras que generaban la ignorancia y las supersticiones. Él vivió una época donde realmente ya se habían logrado muchísimas cosas. Algunas de ellas las ha explicado el profesor. Había otros muchos navegantes anteriores a Magallanes que habían logrado descubrir el sur del Atlántico, navegar por el Índico. De todo eso, de todos esos conocimientos previos se aprovechó Magallanes. Finalmente también de esa competencia feroz entre Portugal y Castilla para dominar el mundo de las especias. Quien controlara las especierías dominaría el mundo desde un punto de vista no solamente económico, sino también político y también, de alguna manera, simbólico. Finalmente, Magallanes tuvo demasiadas dificultades en su propio país y tuvo que emigrar, tuvo que pasar, digamos, su proyecto al país vecino, a la otra potencia, que era Castilla. Allí se tuvo que enfrentar nuevamente con cuestiones que tenían más que ver con una especie de guerra sucia entre las grandes potencias. En este caso, este mapa extraordinario, hecho por Lopo Omen y Pedro Reinel, en 1519, nos presenta un mundo donde la Tierra rodea un solo mar. Es un mapa muy curioso, porque en ese momento, precisamente uno de los autores del mapa, Pedro Reinel, había trabajado para Magallanes diseñándole un mapa donde aparecía un paso que conectaba el Océano Atlántico con el Pacífico. Realmente este tipo de estrategias, por ejemplo aquí el viaje de Magallanes, es prácticamente imposible. El mundo está cerrado por el este y por el oeste. O este otro mapa, donde las islas de las especierías, a la derecha, ustedes verán que tiene un muro que cierra completamente el paso por el este, un muro inexistente, y por la parte occidental tiene una especie de cinturón de seguridad que lo provoca un arrecife coralino, que también era inexistente. Por tanto, se trataba de esa lucha disuasoria de una potencia contra la otra para evitar que el enemigo, digamos, pudiese tener éxito en sus proyectos. Finalmente, la circunnavegación tuvo lugar gracias a Fernando de Magallanes, su proyecto, y también al marino vasco español Juan Sebastián Elcano. Y ellos nos legaron un mundo esférico que rotaba en el universo. Ahora, si me lo van a permitir, muy brevemente, les voy a hacer una vuelta al mundo en 80 miradas, recuperando lo que fue una experiencia personal como investigador, como explorador, en una fiel réplica de esa primera vuelta al mundo de Magallanes Elcano. Justamente en 1990, el buque Antaviana, un barco velero, salió de Sevilla, igual que la flota de Magallanes, para recorrer el Atlántico, haciendo primera escala en las Islas Canarias, en Tenerife, donde pudimos ver las mismas cosas que viera Pigafetta. El árbol Drago, el árbol de la lluvia, el Monte Rosso, la montaña roja, hasta que llegamos a la costa de Brasil. Allí hicimos escala, en primer lugar, en la bahía de Guanabara, Río de Janeiro, y pudimos también tener la experiencia de hacer intercambios con la gente del lugar. Pigafetta nos narraba que por un naipe, una carta de juego, un cuchillo, unas tijeras, les podían dar 6 gallinas. Nosotros, 500 años más tarde, bueno, para tener una gallina nos costaba un buen puñado de dólares. Posteriormente llegamos al Río de la Plata, que es, como ustedes saben, el mayor tajo en la tierra del continente sudamericano. Es un lugar geográfico que propició el primer gran error de Magallanes. En esa situación, estamos en los 28 grados sur, pensaba realmente que había esa conexión entre el océano Atlántico y el llamado entonces Mar del Sur que descubriera Balboa. Allí Magallanes pudo bautizar, pudo llamar a ese pequeño monte que ven ustedes arriba a la izquierda, Montevideo, que está la actual ciudad capital de Uruguay, Montevideo. También allí tuvimos que sufrir las mismas terribles sudestadas y los terribles pamperos. De manera que posteriormente, bajando al sur, ya estamos en los 49 grados del sur antártico, llegaron a una tierra donde todo era absolutamente nuevo. El mundo, la geografía eran absolutamente desconocidas. Estamos hablando de la Patagonia. Allí decidió invernar, debido al cansancio de los hombres, durante 5 meses. Digamos que a esas alturas Magallanes también estaba realmente perdido. Tuvieron, aparte que soportar los amotinamientos de los capitanes castellanos que se enfrentaban a un portugués en esa lucha que yo decía anteriormente entre inteligencias y todo ese tipo de espionajes y controversias que había entre los dos países, también tuvieron tiempo para descubrir una etnia, un pueblo absolutamente desconocidos para los europeos, los tehuelches. Magallanes los bautizó como patagones por su gran corpulencia y porque los pies les aparecían también gigantescos, porque estaban forrados, cubiertos con la piel de un animal llamado guanaco, que los pueden ver ahí también. A esa señora que aparece en una de las imágenes, Luisa Pascual, tuve oportunidad de entrevistarla hace 30 años y fue la última persona, el último, digamos, vestigio de una raza que hoy día está extinguida. Finalmente, Magallanes y su tripulación pudieron llegar al grado 52 del sur y llegaron a las puertas del estrecho de Magallanes. Ahí vemos realmente, son mares tremendos, mares muy difíciles de navegar. El estrecho de Magallanes es un auténtico laberinto de vueltas y revueltas que hoy es difícil navegar, pero imaginen ustedes con las técnicas, con la capacidad de medición que tenían esos barcos, los conocimientos eran muy limitados. Magallanes tuvo la heroicidad de navegarlo no en una ocasión, en 2 ocasiones debido a la deserción de una de las naves, mostrando una pericia realmente extraordinaria. También Hoy día podemos ver en Punta Arenas, la capital del estrecho, monumentos hermosos y barcos museo que ilustran de alguna manera aquella historia desde el punto de vista del patrimonio local. Magallanes también bautizó, denominó la región sur del estrecho de Magallanes como Tierra de los Fuegos, debido a las hogueras gigantescas y los humos que veía durante las noches, donde estaban realmente aterrorizados. Ellos no solamente estaban pasando un estrecho entre dos mares, sino también la noche de los tiempos. Se estaban cruzando porque los pueblos, los nativos de aquella región, desconocían la industria de cómo hacer el fuego y tenían que mantenerlo vivo día y noche. Hoy día, los indígenas de aquellas latitudes, los Selknam, los Onas, los Yaganes, los Saus, los Alacalufes, están prácticamente extinguidos también. Magallanes es conocido como uno de los grandes marinos, el arquetipo de marino y explorador de todos los tiempos, por dos causas fundamentales, dos grandes eventos. El descubrimiento del estrecho que lleva su nombre y el cruce del Océano Pacífico, la mayor masa acuosa de la Tierra. Es un océano donde invirtieron 3 meses y 10 días en cruzarlo. Nosotros con el Antaviana invertimos prácticamente lo mismo, lo cual nos hizo estar un poco avergonzados. Finalmente, después de pasar penosos sacrificios y muchos esfuerzos rodeados por la enfermedad, por los sacrificios y por la muerte, llegaron finalmente a las Islas Filipinas. En aquellas islas pudieron sanar gracias a las frutas y a las verduras que le dieron los nativos, con lo cual pudieron eliminar el terrible escorbuto. Por eso Magallanes llamó a aquellas islas San Lázaro, en honor al santo de Betania que resucitó según la Biblia. De manera que nosotros pudimos encontrar en las Filipinas, 500 años más tarde, que pocas cosas habían cambiado bajo el sol. Gente muy amable que estaba dispuesta a ayudarnos, al igual que a Magallanes, niños sin apenas futuro y también la muerte rondando por todas partes. Tuvimos la fortuna y la suerte de recuperar 7 náufragos que habían desaparecido en un terrible tifón cerca de la isla de Negros, al sur de Dumaguete, camino rumbo que llevábamos a la isla de Zamboanga. Finalmente, Magallanes murió el 27 de abril de 1521 en la isla de Mactán, muy pequeña y cerquita a la isla de Cebú, por inmiscuirse, por meterse en un conflicto tribal que realmente no le competía, no le afectaba, pero bueno, eran este tipo de errores estratégicos que a veces cometían este tipo de genios, de personalidades que para algunas cosas eran extraordinarias, para otras pues cometían fallos. Finalmente, ya la tripulación sin Magallanes pasó por una serie de vicisitudes, de peripecias con diversos capitanes y finalmente fue el marino español, Juan Sebastián Elcano, el que dirigió solamente la flota ya de 2 barcos, quedaban 2 barcos, la nao Trinidad y la nao Victoria, y llegaron a las Islas Molucas, unas islas de origen volcánico donde se producían las ansiadas especias. Pigafetta dice, lanzamos toda la artillería porque era de mucha alegría haber recorrido medio mundo durante 2 años para alcanzar estas preciosas islas.
José Manuel.
De manera
Estamos llegando al final.
Ok, ya finalmente...
Al final del viaje.
¿Ya?
Bueno, de tu intervención.
Ok, perfecto.
¿Terminamos ya?
Sí, sí, sí.
¿Ah, sí? Vale, perfecto. So, thank you. I told them I was going to be very strict with the time, right? So we're moving forward. And the circumnavigation and discovery of the oceans had a very big impact in its time. It still has. So to tell us a little bit more about that, I'm going to give the word to Lawrence Bergreen. Lawrence?
Good morning. Bom dia. So the question is, what does the planet Mars have in common with Ferdinand Magellan, the explorer? And I will try to explain to you why. It actually begins with this gentleman on my left, Jim Garvin, who's a scientist from NASA. Some years ago, I was at a NASA meeting where they were discussing the exploration of the red planet and sending robotic rovers to Mars and exploring Mars robotically. Jim was involved in that. And they would occasionally talk in a scientific way about the spirit of discovery. What was it all about? What did it mean? Why explore? In Magellan's time, it meant exploring for several reasons. For conquest, for religious reasons, for sheer greed, sometimes for glory. Today, ever since the 18th century, it's more for knowledge. It's more of a pure pursuit. And I noticed that one of their spacecraft was called Magellan. And I was, like most people, vaguely aware of who Magellan was, wasn't sure what he did, something about going around the world. And I was a writer, historian, biographer, writing about science and other figures, historical figures, but I was curious to see a little bit more about Magellan. There was very little available about him in English. There was much more in Portuguese, Spanish, French, and other languages. And these separate manuscript traditions didn't necessarily overlap. And so I began to think about a little bit about Magellan and wonder about it, and discovered what kind of records were there from his voyage. It turned out there were quite a lot. He brought along a Venetian diplomat named Antonio Pigafetta, who kept a diary and also some pictures. But this diary was non-specialized, and he described what it was like to sail around the world with Ferdinand Magellan. He was one of the very few survivors. Keep in mind how much courage this took to sail around the world at that time, because anybody who basically went sailing off into the Atlantic Ocean never came back. So this took a lot of guts. Magellan put together a fleet. It took him many years. He tried for years in Portugal to get the backing of King João with no success. Finally went to Spain, which was backing navigators from various countries. Put his fleet together, but he was still considered there an outsider, a rebel. The crew was international. This was not a feel-good United Nations crew. They were very mistrustful, especially mistrustful of him. There were a number of Spanish aristocracy there who considered them, that they were the ones who were really in charge of the voyage, not this upstart Portuguese pilot, Ferdinand Magellan, whom they had hired. There were mutinies, and there was dissension all the way through. Earlier we talked about the monsters the people were afraid of. By Magellan's time, people knew that there weren't monsters out there, that nails would not be pulled from ships by magnetic floating islands and the ships would sink. And they knew there weren't sea monsters, but the real monsters were other people. The hazards that they had for each other, occasionally the belligerent people whom they encountered around the world, although sometimes the people were extremely accommodating and generous, and it varied. So you have to give Magellan and the people who went with him credit for extraordinary courage and guts. So this is a picture of Mars from taken from Earth. So this sense of going somewhere unknown was really what drew Magellan. He was hoping he would get wealthy. His goal, of course, was to go to the Spice Islands and get spices from the Moluccas, to short-circuit what Marco Polo had done. Instead of going overland, which took years to get to the Spice Islands and then years to get back, he thought this would be a relatively short hop. Once he got through South America. He was not aware of the Pacific Ocean, the largest body of water on the planet. If he had known how difficult the task really was, and if he had known the real size of the world, he wouldn't have gone, because it would have seemed too daunting. But he was committed, and so he went. Let me see if I can get the next. There we go. Well, we saw this image earlier of the Strait of Magellan, perhaps his greatest feat, and still considered today one of the great, if not the greatest feats in all of navigation history, was negotiating this strait. There were no maps. Its existence was vaguely rumored. He'd heard about it. Perhaps an earlier explorer had reached it, but there was nothing known for sure. So he managed to sense his way through it, going through it by tasting the water. It was salty, of course, at the ocean. The further he got into the strait, when it started tasting sweet, it's fresh, he knew he was inside the strait. And when it started tasting salty again, he knew he was coming out the other side at the western edge. It happened to be fairly calm weather when he was there, but there were extraordinary disturbances there called willowaws, which were winds that get up to a very high velocity that when tumbling down the mountain, there were glaciers. I went through the strait. I went to some of the high points of Magellan's voyage. Seville, of course, where he began and where many of the records for this voyage were kept. It happened to be a sunny day, a rare sunny day, in the strait, and you can get an idea of the spectacular beauty there. It's really almost a spiritual experience to go through the strait because it's extraordinary. Of course, Magellan was just trying to stay alive. They were slaughtering seals and penguins. They were eating rotten ship's biscuits that were filled with insects. So they were having a much more difficult time than we did. But it's really an extraordinary, if you ever have a chance to go, it's really an extraordinary visit. As Magellan went, this is the Mars connection, he was naming various places, mostly in Portuguese, some in Spanish, that were familiar to him. And what you're seeing here is a picture taken from a satellite of the crater Victoria on Mars. And there was a rover Opportunity that slowly, very slowly, a few miles an hour, was crawling around and inspecting the perimeter of it. At one point, NASA asked me to name some of these features on Mars after features that Magellan had discovered. That would somehow fit or be appropriate. The whole idea of nomenclature of unexplored lands is a very, very interesting subject, fraught with history, sometimes changes when there are political upheavals, says a lot about who is doing this and who the explorers are. So I picked out about a dozen or 20 places which NASA assigned to these names after some of the highlights of Magellan's voyage. And I don't know if I'll ever get to visit, but that's what it looks like from space. And when, of course, Magellan was killed in the Philippines, as you heard, so he never got to return and see what happened. There were just a few survivors, and the one who you mentioned, my colleague Elcano, was very problematic for Spain because he was a Basque. He was not part of the elite officer class. And as a Basque, he was somewhat of an outsider. And he led about 18 or 21 people back to Seville aboard a ghost ship. And just to give you an idea of what this was like, this was not like astronauts returning to a ticker tape parade. When they returned, it was around Easter Sunday, they went on took a tour of penance. They went on bare knees over bare stones till their knees were bloodied in an act of penance, and then went to church to pray for all the sins that these few survivors had committed during the voyage. So they were not really treated as heroes so much as a kind of very special penitence. And later on, there was a modest statue put up for Magellan and the other survivors in Seville, but it took him a long time to achieve the place in history. How much more time do I have?
Nothing.
I'm out? Okay. I'm sorry I asked that question.
No, that was a very good question. Okay. Thank you.
All right,
thank you so much, Lawrence.
Obrigado. Thank you. Yeah.
So future will bring us for sure many voyages, many trips, hopefully many of them to Portugal, that's for sure, either in our planet or in the universe. So to bring us news from Mars, I'll give the floor to James Garvin.
Well, thank you. And so connecting, if I can have the slides,
connecting 500 years of history to the next 500 is really a tough job. And in 10 minutes, I'll do my best in honor of Magellan and the Renaissance explorers we've been talking about. The first thing I want to point out is that wherever we go, wherever we explore, we encounter new oceans. And some of you may know, Star Trek, space is the final frontier, and I think that's not the right word. Space is our cosmic ocean. It's a forever frontier because it's with us wherever we go. It was with Magellan, with his navigation. And today we sail cosmic oceans with new kinds of messengers. They're not people. They're messengers written in the physics of how our place in space works. And in doing that, we find our new homes. We see the homes we could have as people. And so I want to talk about this Magellan legacy over the last 500 years in the spirit of the space exploration we're doing. Some great explorers are here, Alan Stern, Lindy Elkins-Tanner, and others who you'll hear from later to inspire how we're exploring. But let me give you a broad brush picture. It all starts with our profoundly ocean world home, planet Earth. Truly a spaceship. Like Magellan's caravels and other vehicles, it is our spaceship. And plenty more to explore and learn. But as we look at Earth now holistically, we see the value of understanding ocean worlds beyond our home. And that really connects us to the ocean exploration of 500 years ago by the great explorers like Magellan. He sailed tangibly and physically on the seas of our planet as his technology of transportation. Today, the exploration craft are different. They fly to places to ride the waves of the echoes of the universe. You saw the Planck measurements, those that won the Nobel for John Mather, that talk about the Big Bang. We are embarking now on voyages of space, internationally connectedly, that will forever change how we see the cosmos. And I'll talk about the James Webb Space Telescope in the legacy of Magellan in a minute. But let's just think for a minute how far we've come. 500 years, and yet 50 years ago, probably 50 years ahead of its time, humanity went to the moon. We sailed 400,000 kilometers of cosmic oceans to land 6 times on the moon with people like us, brave explorers. And those people changed the way we saw our ocean world forever, in the timing of things, in the collisional records, in the way things work. That's what exploration did. Magellan and his team, Elcano, did the same 500 years ago. So we went to the moon, and the moon inspired us to see new questions. And we always were asking these questions. Are we alone? Where the heck are we going? Why are we going? Where did we come from? These are big questions. And we still ask them, but now our tools are written in different ways. So 20 years ago, NASA launched a mission named for Magellan to map probably the most mysterious object in our solar system, now thanks to Alan's mission to Pluto, the planet Venus. And Magellan mapped Venus using the eyes of electromagnetic radiation and showed us what I believe, and some of us believe, was a former ocean world. How does a planet lose that record? This is some of the magic of our solar system that we can uncover. So the ancient Venus, perhaps oceanic, to the modern Venus, hostile, foreboding, robotically inaccessible almost. These are the kind of legacies that exploration have given us. What will we discover next? So as we look out, you heard from Larry and others, we look out to the 4th planet, planet Mars. And what you first see is a dust bowl of a world, perhaps frozen in time, doesn't look most hospitable. You wouldn't think that sailing the cosmic ocean would make Mars special. And yet, lurking in its beautiful rockscapes, Ansel Adams, the photographer, would have been proud of what we can now do on Mars. There are records written in stone. Those rockscapes are the spice trade of science today in space. They show us records of water, buried records of perhaps cryo-oceans on another world where we will go. Inspired by Magellan, Elcano, Prince Henry, and all the other explorers, we will, women and men, go to Mars. That's in our destiny, and we will get there. And one of the steps we will take soon is to return Mars to Earth. And that's important because what Mars is telling us is lurking in the records of meteorites that we can now see. I'm showing you here the nanoverse. We can now look at the Mother Nature's records from Mars at a billionth of a meter scale to see what they show us about what we'll get when we go. These X-ray computer tomography images, Magellan would have been proud to have them on his voyage. I doubt he would have been processing 20 gigabytes of data, but in any event, we can see inside the mineral records of water frozen in minerals on Mars as we explore Mars for those elusive records of life. These are the spice trades of today. And continuing, we look at these oceans in space through the eyes of basically the immersive virtual reality of exploring, the tapestry of the atmosphere of Jupiter, the hidden oceans of Europa. We won't sail them like Magellan. We will visit them on the shoulders of robots, inspired by the questions Magellan asked, and ask there and in other places, are we alone? Now, I love to show this picture because it shows how far we've come. Billions of kilometers from Earth, looking back from the international mission known as Cassini, backlit by Saturn. We see our neck of the woods, our neighborhood. It's like looking back at Spain and Portugal from Magellan's voyage. Here you see the Earth and Moon and Mars and Venus from 1 billion kilometers. This is how far we've come. We moved ourselves there without going. And that's what 500 years of exploration has done. Soon, new ways of connecting to these worlds will be possible. Missions such as Dragonfly, that you'll hear about later, recently selected competitively. Like Magellan, we compete for our exploration to do the great things that women and men do. This mission will take mobility to the air on a world that's a large moon of Saturn. And then, of course, new worlds, new discoveries, new oceans. Lord, what we would have thought about places like Pluto, Ultima Thule, even Enceladus, as being worlds that could contain fluid records of oceans in different ways. It's an oceanic universe, and the sailors of the Renaissance got us there. Now, today we look beyond. But before looking beyond, we remind ourselves that we live with a star every second. Our sun is the source of our space weather. And as we go into space ourselves, we will be worrying about space weather, not the kind of weather that Magellan set forth. So what's ahead? In the next 50 years, we will sail the cosmic oceans, riding on the photons that give us the records of space, seeing not only the stars and galaxies, but the hidden dark matter and dark energy that we know connects these things to us. How will that be? For all of you, you will be members of a new generation, not the internet generation, the web generation. Because in the next couple of years, the people of planet Earth will launch a telescope with an aperture the size of the sails of Magellan ships. And that aperture will change how we see our universe, not by a factor of 2 or 3 or 4, but by factors of 20 or more. We will use this vehicle, you can see women and men for scale there at the bottom, the James Webb Telescope, to ride the records of the universe and the photons that we capture, the spice trade in photons, to see what we can see, to actually be able to measure exoplanetary worlds and their atmospheres from Earth orbit, or Earth-Sun L2. These are the voyages of the future that you're all part of. We're all part of it. It are the people's missions. So as we look into space, we look out and then we look back to where we've been. Because we're going back to the moon. This woman here dressed in a new spacesuit on the moon, we hope will be there in the next 5 or 6 years, returning us to a place where we knew there were records left to discover, the records of ancient Earth entombed on the moon. The moon is a destination. The cosmos is a learning place. So as we look forward, I'd like to see this artist rendering filled in by all of you in the legacy of Magellan. This is not a picture. This is a drawing from the mind's eye of women and men. And that woman there, with her assets in space, robots, drones, exploring Mars, is in our destiny in the way that Magellan and his crew gave us that first orbit of planet Earth. So I say, let's go back to the oceans, but the oceans of space, the cosmic oceans. Carl Sagan said it very dramatically and eloquently some 20 years ago. We sail those oceans to never wait to wonder about what we're going to find. This brings with us not only economic gain, not only technology, but inspiration, innovation just to go, and the interconnectivity to all be there together as we discover what we don't know. And that's what it's all about. What we don't know, we discover by exploring. And that's the legacy of Magellan and his crew, and that's why we go. So the forever frontier waits. Let's go.
Thank you so much, Jim. Well, it said questions, but we don't have time for questions.
Oh. Yeah, well,
So, but I'm sure you will be glad to answer any questions in private during the coffee break or the lunch. Thank you so much. This was really inspiring, and I'm sure the lessons that we heard here, the lessons from our past, will bring us a much, much better future for the Earth, the universe, and especially to all of us. Thank you so much.
Thank you, gentlemen. You know, as explorers, probably the most annoying question we all get is what's left to explore. And I think when you start heading your eyes towards the stars, you think it's just infinite. There is no end to exploration. And I think even a lot of our oceanographers would agree the same thing looking downward, that there's so much we don't know. So, gentlemen, thank you very much. So my question is for all of you, what were you doing this past New Year's Eve? Some of you getting ready for parties? Parties? Anybody getting ready for parties? Well, no, he wasn't, because we know true explorers, what they were doing. They had their eyes glued to the stars, watching the ultimate journey as NASA's New Horizons spacecraft made a flyby the Kuiper Belt object and the furthest exploration of the world. Well, it's my distinct honor to introduce a name you've heard several times throughout this event. Please give a warm welcome to Dr. Alan Stern.
Okay, is the mic up? Good morning, everybody. Let's see if we can get the first slide. And I think they're going to be taking the stage apart, so it should be interesting. Okay, there it is. Well, as you heard, I'm going to talk to you about NASA's New Horizons mission, which has conducted the farthest exploration of worlds in history. Our journey of over 5 billion kilometers is so far that if we compared the distance to the edge of the city of Lisbon to be equivalent to the historic Apollo missions that traveled to the moon 400,000 kilometers or 250,000 miles away, then the distance that New Horizons traveled to explore the distant outer solar system is equivalent to Magellan's circumnavigation of our entire planet, a factor of more than 10,000 times farther. Our destination is called the Kuiper Belt. It's the third zone of our solar system, and it was not known when I was a boy. When most of the people in this room grew up and you learned a little bit about the architecture of our solar system, you learned about the 4 rocky planets close to the sun: Mercury, Venus, Earth, and Mars. And then, beyond them, the gargantuan giant planets, Jupiter, Saturn, Uranus, and Neptune, that were then called the outer solar system. But our view in the middle and even the later decades of the 20th century was myopic. It was only in the 1990s that we discovered the third zone of our solar system, the Kuiper Belt. This is where Pluto and a whole new class of small planets called dwarf planets orbit, the most populous class of planet in our solar system. And New Horizons was dispatched to be built and flown to be the first exploration of this third zone of our solar system, the first exploration of Pluto, the first exploration of dwarf planets, and the first exploration of the building blocks, the so-called Kuiper Belt objects, out of which these small planets were built. We built this spacecraft to do the job. This was a considerable project. Over 2,500 men and women worked to design and build, test, and fly this spacecraft and its launch vehicle. Over a period from 2001 to 2006, They worked literally 52 weeks a year and literally 7 days a week against the clock because we had to make a very special launch window in January of 2006, only a 3-week period in time, where it was possible for us to launch from the Earth and fly past the giant planet Jupiter to receive a gravity assist to speed us on the way to Pluto. This is a very sophisticated small spacecraft, smaller than this piano. It's nuclear powered. It communicates by radio back to the Earth. On board the spacecraft are all of the flight systems that are required for this epic journey, now over 14 years, across our entire solar system to make explorations at the very frontier. So on board are communication systems, thermal control, command and data handling, propulsion, solid-state recorders for all the data, and 7 scientific instruments, cameras and spectrometers and other devices to explore the targets at the edge of our solar system. You can see there a dish antenna that we use at the top of the spacecraft to communicate back with the Earth. And you can see, because there are people there, just how small this vehicle really is. And it had to be very reliable because it's going on a one-way journey with no chance for repair, no chance to bring it back, no chance, if we got it wrong, to change the design afterwards. And in addition, we had to break the mold on price. This mission, which is our generation's Voyager, the storied mission that explored the giant planets, was dispatched at only 20% of the cost of Voyager. And we had to figure out how to do that and learn how to do outer planet frontier exploration at a brand new price point of only 2 dimes on the dollar. We launched this spacecraft on an Atlas V 551 launch vehicle, the largest launch vehicle at that time in the US inventory, on the 19th of January 2006. And that flawless launch put our spacecraft at a speed which set a record, the fastest spacecraft ever launched. The Apollo journeys, which we celebrate today, 50 years later, traveled at a burnout speed of 25,000 miles per hour, almost 40,000 kilometers per hour. And it took almost 4 days to reach the moon. New Horizons left the Earth and reached the orbit of the moon 9 hours later and traveled at that great speed of about 1 million kilometers per day for the next decade to reach its first scientific target, Pluto. I show you here the best picture of Pluto ever made before New Horizons. You can laugh. I took this picture myself with the Hubble Space Telescope, and we wrote scientific papers about this picture and others like it. This is a testament to how far away Pluto is, that even with the biggest, baddest gun that we have, the Hubble Space Telescope, that all we could see was a bit of a smudge, a little bit of a disk of a planet with some evidence of a polar cap at the northern end, if you can believe that. New Horizons replaced all of that by flying up close and personal, directly through the Pluto system to explore the planet and its system of 5 moons. Behold Pluto. This is our primary target. And what a world it turned out to be. I like to say that the solar system saved the best for last, because we discovered in Pluto a world we had barely imagined, a world with an atmosphere, a world with mountain ranges and glaciers and flowing ice, a world with tectonics and ancient and young terrains, and strong evidence that it has a global ocean of water beneath its ice. We had no idea that small planets could be so beautiful or so complex or so active so long after their formation, 4 billion years ago. Our exploration of Pluto lasted only a few days, and then we were gone, looking back at the beautiful planet and its blue atmosphere. And then we launched onto the second part of our mission to explore the Kuiper Belt and these planetesimals, these objects out of which small planets like Pluto were made. The Kuiper Belt is that ring or disk of material that you see beyond the orbit of Neptune. It was named after the Dutch-American astronomer Gerard Kuiper, who first postulated it in the 1950s. But as I said earlier, it wasn't discovered until the 1990s. So New Horizons continued beyond Pluto out into the frigid Kuiper belt, where temperatures are nearly absolute zero. Using the Hubble Space Telescope again, we searched for targets that the spacecraft could fly by. We found 3, and then we selected one of those 3 with the difficult-to-remember name 2014 MU-69. So we nicknamed it with a Latin phrase, Ultima Thule, which means beyond the farthest known world, which is exactly what New Horizons and its crew were doing, exploring beyond the farthest frontiers that had ever been attempted before. And by the way, our flight crew on New Horizons is only about 50 people, so about the size of the Corps of Exploration of Lewis and Clark. A group of just 4 dozen scientists, engineers, and flight controllers who, round the clock, staff our mission control and conduct this entire flight operation from the Earth to the frontier of our solar system. Now, I want to give you a bit of an idea of how difficult it is to chase down a target like Ultima Thule. It's not the size of a continent like Pluto, but you can see there, it's just the size of a mountain block. And think about this, the spacecraft is traveling 32,000 miles per hour, about 50,000 kilometers per hour, in the darkness of the Kuiper belt, where the sun is 2,000 times fainter than it is outside in daylight on the Earth. And we were chasing down an object not much bigger than the city of Lisbon, with only one chance to make an intercept, and the need to make that intercept not only on a particular day, but on a particular hour and a particular time of the hour that was so demanding that had we missed the target, if we had arrived early or late by more than 4 minutes, there would have been no photographs. There would have been no data from that flyby. In fact, the New Horizons team, after working for 3.5 years to target this flyby, to make this intercept work, after our flyby of Pluto, arrived at Ultima Thule only 22 seconds off target after traveling 1.5 billion kilometers and 1,000 days. Think about that. 2 days ago, when I arrived on a 2-hour flight from Zurich to Lisbon, the airliner was more than 10 times later than we were after a journey of 1.5 billion kilometers in 1,000 days. We first spotted Ultima Thule in our cameras on board the spacecraft last August at a distance of almost 200 million kilometers away. Imagine a target about the size of the city of Lisbon, whose reflectivity is about the same as garden variety dirt, illuminated by a sun that's 2,000 times fainter, and yet our telescopes and CCD cameras could spot it. And you see it slowly moving here in the distance, in that red circle. You'll see it faintly moving against the star fields of Sagittarius. There it is. That's Ultima Thule in the distance. And even as we traveled on the final weeks of the approach, as we got close, in the last day, it became a real place that we could see as we zoomed up to it at this tremendous speed, rotating before our very eyes. And what a scientific wonderland it turned out to be. Meet Ultima Thule. This is an ancient building block, 4.5 billion years old, frozen at a temperature of only about 40 degrees centigrade above absolute zero, preserved since the earliest days of our solar system. And nothing like this has ever been seen before. It's called a contact binary. It consists of 2 objects that formed close to one another and then merged. And as you can see, there are no signs of violence in that merger. A very gentle merger, so gentle we sometimes call it a docking. But these are large objects. Ultima, the larger of the 2 lobes, is about 20 kilometers in length. And Thule, the smaller of the 2 lobes, the head of it, if you will, is about 14 kilometers across. And you can see how varied these surfaces are. They're made primarily of water ice and methyl alcohol. They're red because of organic molecules draping the surface created by the interaction of sunlight, ultraviolet sunlight, with the chemicals on the surface of Ultima Thule. This is a time capsule from the birth of our solar system, and nothing like it has ever been seen before. Here it is up close. It's teaching us brand new things about the origin of our solar system. You can see in this sequence of images just how flattened it is. Now, who ordered that? We had no idea before the exploration of Ultima Thule on January 1st this year that the solar system made planetesimals that were actually disc-shaped or lenticular. And now we're going back to the drawing boards to understand whether aerodynamic erosion or whether some process involving spin angular momentum or something else created these shapes. But they're completely unlike what had been predicted in computer models before this. Well, let me turn to another aspect of the flyby of Ultima Thule. You know, when NASA presents for you the public relations around a flyby, you see us in press conferences, and you see us in the newspaper, and you see celebrations in large rooms with lots of American flags. But you rarely get a chance to go backstage to see what it's really about. And so I want to give you a glimpse of what it was like for some people on our team in the wee hours of January 2nd this year, as the first images were coming back to Earth across this great gulf of space. And our team knew that we had succeeded. So come with me into the back rooms of our mission control for just a moment to see what it's like to be part of the crew of a robotic space explorer that's making new discoveries for the first time, seeing an ancient object. You can feel the energy in that room. This is our geology and geophysics team when they saw the very first image, perfectly centered in the field of view by that explorer, and we knew it had worked. This is our navigation team at the moment that they knew they had succeeded in making that intercept on time and on course. And the celebration was intense. People had worked so hard to achieve this, but it didn't take long before we went back to nerding out. Before we started to analyze the images and the spectra to come to understand what is there. And in fact, we have now already, as of just a little over a month ago in May, made the first scientific publication on the cover of Science magazine. For us, for scientific explorers, this is the cover of the Rolling Stone. Okay, the Rolling Stone for nerds. But more papers are following, and more discoveries are following, and the data is coming back every day and every week from the Kuiper Belt. We filled the solid-state flash drive memories on board the spacecraft so full that it will take more than another year from now, more than a year and a half since the beginning of our data downlink after the flyby, to get all of the results back to the Earth. And the journey continues. New Horizons is now flying outwards, still at a speed of about 1 million kilometers per second, into the Kuiper Belt, farther and farther each day. And it is in perfect health, almost 14 years after launch. We're not using any of the backup systems. The onboard nuclear battery is capable of powering the spacecraft for another 20 years. We have more fuel on board now than it took to target the flyby of Ultima Thule, and we are beginning to look for another flyby target, still farther out, to go on exploring. Thank you for having me here today. Always keep exploring. Thanks, Ricky. Here you go. All right. Thank you. Thank you.
So, Alan, I have a question. What are your New Year's Eve plans for this year?
They're going to be a little quieter, in a little smaller group.
Now, we know that the fabric of exploration isn't just white dudes like you and I, right? So I think it's time we introduce some of our female scientists.
Let's do that. Yeah, I have the great pleasure of introducing our next speaker, an explorer herself, Dr. Lindy Elkins-Tanton. Let me tell you a little bit about Lindy. Lindy, like myself, is a planetary scientist. Actually, Lindy is an Earth and planetary scientist. She is a professor of Earth and Planetary Science at the Arizona State University, which is one of the largest universities in the United States. And she just stepped down after a successful tenure of the School of Earth and Space Exploration there at Arizona State University. But most notably, and the reason that she's here today is to talk to us about a new space mission, which she leads as the principal investigator, a mission to something unlike anything that we've ever explored before, a metal world in the asteroid belt named Psyche. Let's bring out Lindy Elkins. There you go.
Hello, everyone. The last time, wait, can we just wait 1 second on that? It's not possible to wait. Thank you so much. Let me just introduce the video with one sentence before we start. And the last time I was so fortunate to speak at the Explorers Club, I was talking about expeditions to Central Siberia, where we were understanding what caused the end Permian extinction, the largest extinction in Earth history. But today I'm here to talk about what Alan just introduced, a spacecraft that we're building right now, a robotic spacecraft that's going to go visit for the very first time a world made of metal, not a world of rock or ice or gas. And so what you're about to see is a video we think of as our mission trailer, kind of like the trailer to a movie that you're going to see in the future. So please, your introduction to Psyche mission.
It's a shame, but living in the city, very rarely do you get to see stars.
I feel like I have a new connection to them in a way that I haven't before.
If I'm out in the desert and I look up at the sky, you just see millions and millions of places that we should be going.
It's almost baked into our DNA, the desire to go and explore, right? That's the whole reason why we left the forest and then traveled across oceans just to see what's out there.
I was born in 1969, which is the year we landed on the moon. So I am a space baby.
When I was a kid, there were guys driving cars on the moon. They're driving cars on the moon. That's so cool, right? I want to do that.
All the rocky planets that we know of all have got a metal core in their center. And especially for the Earth, it's the source of our magnetic field. But we don't know a lot about our core. What we've learned about it, we learn indirectly because we can't go there.
It's too hot. The pressure's too high. Our instruments would melt. Can't drill a hole that deep in the Earth or other planets. It turns out we can study a planetary core out in space because there's this one object called Psyche.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
It is the only asteroid that we're aware of that is 95% metal or more and is really huge. It's about 200 kilometers across in one axis.
So it's about the size of Massachusetts.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
The first thing that came actually was the theory. Some people from Jet Propulsion Laboratory contacted me and said, we would like to plan a mission that would test your hypotheses.
And that starts you down a road that takes years. So we wrote a proposal to send a NASA spacecraft to visit this big ball of metal. And then about a year ago, Lindy gets a phone call. You win. And then we're all like, oh my God, now we have to do it.
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first metal object that humankind has ever visited.
We've been approved to go in August of 2022. So we talked with our mission design and navigation team, and in fact, they were able to come up with what is probably the most optimal trajectory, doing a Mars flyby.
Flies past Mars, gives us a gravity assist, uses that propulsion system to then slowly creep up toward the end of 2025, getting there in early 2026.
SSL is building the solar electric propulsion chassis. When we do the mechanical, physical integration of each instrument on the spacecraft, we'll work hand in hand with each of the providers to get out to Psyche and do a full discovery mission.
We've figured out a way for many, many people to build something together so complicated, no one person can understand it, but it all has to work together perfectly for decades without fail.
Just the fact that these things work at all is a thrill. It's just a testament to the engineers at JPL and the companies that we collaborate with, that they can build these things.
It's exciting for me to be able to be a woman winning and leading a deep space mission. The only previous woman who competed, won, and led a deep space mission was Maria Zuber, who was my friend and mentor at MIT. And so my drive is to make everyone feel welcome and to have every voice heard. We want as many undergraduates as we can. We want to involve as much of the public as we can. We want people to feel like this is their mission.
You get that first picture back, and one of the first things that goes through your mind is, oh, thank God I didn't leave the lens cap on. We will put our pictures out there as soon as they come down. So we'll discover at the same time that the public discovers. We'll be scratching our heads, and it's like, I don't know what's going on. At the same time, everybody else is like, wow, what is that? I don't know, let's figure it out.
I did get to look at Psyche through an optical telescope in my backyard. Some wonderful colleagues brought over their telescope on a fortuitous night. It's a very, very tiny, faint dot. And that made a bunch of us cry, to think that we could send something to investigate that speck of light.
We can understand this universe that we live in. We can explore it, we can learn about it, and we can be a part of something which is much bigger than just us or just this planet. We will see new things when we visit a world made of metal.
So now you have the whole introduction to the mission. I'm just going to say a few more words about it and tell you a tiny bit also about Interplanetary Initiative before I step off the stage. In that video, you met a lot of the leadership of the Psyche mission. Everybody you saw interviewed is actually an engineer or a scientist who's working with us every day. We've been working on this since 2011. We've really bonded together into a group, and it's a diverse group, as you see, which I really love. The thing you saw in this video that's not real are the images of Psyche, like this one. I worked with a fantastic Hollywood artist named Peter Rubin, and I told him everything I knew about the science of what a metal world could look like, and he made it into art. But the thing I'm here to tell you today is everything that we know about Psyche right now and that I'm telling you is probably wrong. And when we go out there and we find it, it's going to be something completely different, because that's what actual exploration is. That's what it is when you go actually into the unknown. This is not a place that humans have ever been before. These are all guesses. They're based on the best science we have, but they're just guesses. And so this was the cover art for the first of our two big proposals we had to write to compete to win this mission. This one was about a 250-page proposal, and you can now imagine that this is the moment of a hit-and-run collision, one of those collisions we think knocked the rock off the outside of that metal core on that little planetesimal. It's just a hypothesis. It's the best one we've got. I go around the world talking about this, and I ask people, what do you think Psyche could be? And everyone's best guess is it's the metal core of a little planetesimal that had the rock knocked off it, even though it would take 4 to 8 of these collisions to knock off the rock, and no other collisions that added to it in between. So it's improbable. And yet the other ideas we have for what Psyche is are even less probable. So it's going to surprise us, whatever it is. So here's a familiar map, and this is the size of Psyche. So it's a big object. It's about 1% of the mass of the asteroid belt. And yet, as we explained in the video, we've never seen it as more than a spot of light. Even in the Hubble Space Telescope, it's just 2 pixels. So it's far away. And here's that same image from my backyard. That's what we know about Psyche. We know about the qualities of its reflected light and its radar. That's how we know anything about it. So these beautiful pictures of the metal surface, they're just a guess. I keep reminding people. But what could a metal surface look like? Well, this is what an impact into metal looks like in the laboratory. If you use a high-speed gun like at the Ames Research Center, it creates a crater that looks like this. Now, if you're familiar at looking up at the moon or looking at other rocky bodies, you know that when a high-speed, a hypervelocity object hits rock, it spews out those ejecta flaps, but then they fall down onto the surface again. But here, they froze before they could fall, because they're metal. Now, we don't expect giant vertical ejectoflaps on Psyche. The scale is wrong. But we might get frozen turrets. We'll get tektites, blobs of frozen metal that came out of these impact craters and may cover the surface. So many people around the world are trying to figure out right now what a metal surface might look like, but this is one of the inspirations. We're going to see something different. So a few thoughts to end with, and I want to explain to you what we're doing in the Interplanetary Initiative at Arizona State University. The Psyche mission is a part of this initiative. I think all of us here feel this, that exploration is a human imperative. And this is my finger pointing at some Gamble's quail tracks, which somehow feels evocative to me. And what we're trying to do in this initiative, it's something that President Michael Crow and I started 2 years ago. We're trying to bring together all disciplines together to look at our positive human space future, both robotic and human-enabled. We believe that space allows us to envision our better selves. And so often the landscape of space exploration is a NASA or an ESA astronaut on this end, and then a giant wasteland, and then over here some futuristic sci-fi writers. We want to fill in that wasteland. We're inviting people who do theater and music, and people who are sociologists and psychologists, and we need theologians and policymakers. All the parts of human endeavor need to come together to make our interplanetary species what we can be, what we know that we can be. And so I would like to invite you to join us in creating our space future and get in touch with us at the Interplanetary Initiative. My little informal memo for it, or motto for it, is everyone is invited all the time. And we're discovering how to put together next generation research teams which do non-incremental work that really go after the big questions. We are working on how to educate our undergraduates so that they're ready for the jobs of the future, the jobs that we don't even know what they are right now. And we're working on bringing all disciplines into the fold. So thank you so much for learning today about Psyche Mission. We hope you'll join us on our journey and also join us in helping to create our human space future. Thank you very much.
Thank you very much. That was really
thanks so much.
That was
all right,
inspiring.
I appreciate it. Let me leave this here.
Wow. You know, earlier I said that the Explorers Club was about accomplishing the impossible. You know, maybe we have to modify that. It's really about making magic real. I think that you look at so many of these things. Don Walsh, when you did your dive in 1960, some of the things that you're seeing now weren't even thoughts of scientists. And now, you know, we see them coming forward. You know, the future to me is so exciting. I mean, I think as humans, we just have to make sure that we're able to stay on this planet long enough to see these, and we'll talk about some of those things later. So if I were to ask scientists what the holy grail is in their field, you'd get sort of all sorts of answers. And you know, earlier it was getting to the moon. To me, personally, the next great discovery is going to be life itself on another planet. And that's the science of astrobiology. Our next speaker is a native of this country who, for her exceptional and outstanding work in science, was appointed an officer of the Military Order of St. James of the Sword by the President of Portugal. It's my honor to introduce Dr. Zita Martins.
Okay, so I'm actually going to talk about astrobiology and the origin of life on Earth and in other parts of our solar system. So one of the big questions in terms of science, a crucial question, is actually how did life originated here on Earth and potentially in other parts of our solar system? So if you think about the basic unit of life, the cell, and if you consider the cell as a little house, the building blocks of that house are the molecules, organic molecules. So scientists are still debating how we go from having simple building blocks of life, so organic molecules, into having the basic unit of life, then we develop into more complex forms of life. So one of the theories that we have in science about the origin of life is that those organic molecules were formed outside of the Earth, and then they were brought to our planet by comets, asteroids, and meteorites. And so the question is, okay, when that event happened. And we have to question that. So the main question is when. We know there was a period on the Earth's history since its formation, roughly 4.6 billion years ago. That's when the solar system was formed. That's also when the Earth was formed. Until roughly 3.8 billion years ago, when the Earth was heavily bombarded by comets and asteroids. And so you're thinking, okay, that's very nice. We're having all those comets and asteroids bringing the molecules of life into the Earth, but we can't travel back in time and see that that actually happened. Actually, we can, because we have samples from that time, from the time that the solar system was formed. And those samples are called meteorites. All the meteorites that we know and we have in the collections, in the museums all over the world, they are very rich in iron. So you can see some of them here. And I also brought a slice. So the meteorites are much bigger than this. This is just a slice of a much bigger meteorite. And then there are much interesting meteorites, the ones I study in the lab, that are full of organic molecules. Those are the one. And I also brought a very tiny one that I have here in my hands. So those are very interesting because they have not been severely modified since the solar system was formed roughly 4.6 billion years ago. So by studying this type of meteorite, I can actually say which organic molecules are present and which organic molecules were delivered to the Earth just before life originated here on the planet. The question is here now is, okay, we know the meteorites. Where do the meteorites come from? So the meteorites, most meteorites, they come from this asteroid belt located between Mars and Jupiter. So this is a really nice way. We don't have to travel to the asteroid belt. We have the samples that fall to the Earth every day, and then scientists collect the samples here on Earth. They either go to remote places like Antarctica every year. So I have colleagues that spend every Christmas there in Antarctica collecting samples and then sending those meteorite samples to meteorites. So people like myself can analyze the meteorites and determine which organic molecules are present. That's a very nice way. But alternatively, we can also go and visit an asteroid. And that's a really cool way to explore our solar system. So I'm showing you here an image from a space mission. This is the Yabusa 2 space mission. This is a Japanese mission from JAXA. And this is an asteroid called Ryugu. This image is from last summer. The date is here. And the interesting thing about this is the first time that a space mission landed on an asteroid and is going to bring back samples of an asteroid back to the Earth. So in December of this year, the journey with the samples back to the Earth will start, and then next summer we'll have samples to analyze. I'm talking also about this mission because despite being a Japanese mission, I'm part of the team, so it's always very an emotional moment to be part of a mission like this, and also to have Portugal involved in this sort of analysis. But it was not just the asteroids that visit us during the late heavy bombardment. Also comets visited us during that period of time and brought lots of organic molecules. I'm actually showing you here 11th century tapestry. And if you look here, this is not a star. This is Comet Halley. I'm sure all of you heard about Comet Halley. And Comet Halley already visited us periodically, at least since the 11th century. Since then, since the 11th century, we evolved and science evolved a lot. And so we had a space mission, a European space mission to a comet called 67P, also known as Churyumov-Gerasimenko. And this was a very exciting mission. Again, as Europeans, we take pride in doing and having space missions, because obviously we don't have it as frequently as the Americans, so we're always very proud when we have a very successful mission. So this mission was launched in 2004, more or less, and it took roughly 10 years to arrive to this target. It was called the Rosetta mission. And what was found in this mission is that the comet was full of organic molecules, including hydrogen sulfide, formaldehyde, etc. This means one thing. First of all, well, it means two things. It means, first of all, that the comet was full of organic molecules that may have been delivered to the early Earth, and so it is important for the origin of life. But because, as I said, it contained organic molecules such as hydrogen sulfide. And if some of you know a little bit about chemistry, you know that hydrogen sulfide, it stinks. It smells like rotten eggs. So this comet, even though it's very interesting, it stinks. It really smells like rotten eggs. In terms of space missions, obviously the comet I just showed you is very nice. But in terms of studying the origin of life, we want to try to study objects that are extremely pristine. This means that we want to study a comet that has not entered the inner solar system. Because as soon as a comet enters the inner solar system, it flies very close to the sun, and it starts to sublime or to melt the ice. And so the European Space Agency just selected last week a mission called Comet Interceptor. Is going to be launched in 2028, and it's the first time ever that a space mission will analyze a comet from the outside. So a comet that has not entered the inner solar system. Again, as I said, this is a European Space Agency mission. The PIs are British, and again, I'm very proud to say that I'm the Portuguese representative, so we will have the Portuguese flag also involved in this space mission, and this is exciting. It's always very interesting to talk with people outside of the planetary science field. When I said this was a very fast mission, it's actually called Class F from fast mission, and I said that the launch is going to be in 2028. My colleagues, my friends stared at me and said, look, this is like 10 years from now. How can you say this is fast? But it's a completely new field, and it's interesting to see that in terms of planetary science, we always talk about 10 years, 15 years. So in the next 10 to 15 years, I'm going to be very, very busy. In terms of origin of life, so I talked about the origin of life a little bit here on the Earth and how comets and asteroids may have contributed to the origin of life on Earth. So the question is, did life originate in other parts of our solar system? And the answer is maybe. So planetary scientists, and in particular astrobiologists, what we know is that we have to look to places in our solar system that have three things. First of all, we know that all life needs liquid water. The second one is nutrients, and the third one is a source of energy. So we look into places in our solar system, planets or moons, that have those three main key things for habitability. So I'm going to show you 3 locations in our solar system where scientists are targeting and searching for signs of extraterrestrial life. Target number 1 is obviously Mars. This is a real image taken from the Viking 1 mission in 1976. The Viking mission was the first, and until today, the only life detection mission. In 1976, they didn't detect any forms of life on Mars for different reasons. Reason number 1 was technology was not as advanced as it is now in 2019, and also because they were looking into the wrong places. They were searching on the surface of Mars, and we know now that Mars is not the perfect place to look. The surface of Mars is not the right place to look for signs of alien life. So we keep on insisting, and we will go to Mars. And again, the European Space Agency will have, together with NASA, a mission to Mars called ExoMars that is hopefully, if it doesn't get delayed, get launched next year. Another place where life may exist is this moon. It's called Europa. It's a moon of Jupiter. Again, this is a real image taken from the Galileo mission. This is an icy moon, and as you can see, it is full of those dark patches and fractures. So what the scientific community believes is that beneath the layer of ice, there is an ocean of liquid water that is forcing the ice to break, and that's why we have those cracks. And so this is important because where there is liquid water, potentially there are forms of life. So this is very, very exciting. Another place that may have life is another moon. This time is called Enceladus. It's a moon of Saturn. This is again a real image taken from the Cassini mission. And as you can see, this is again another icy moon full of fractures. And this time we have direct proof that we have water beneath this layer of ice. So what you can see here, those are not lights, those are plumes, geysers, that come out of the fractures. And where there is geysers, there is at least water or water vapor. And so this is important again for the origin of life, at least in this place. Maybe there are forms of life. In fact, the Cassini mission did not only detect water vapor in these plumes, but it also detected methane in this vapor. And so methane can have an origin by two sources. Source number one, it may be a geological process where a rock called olivine reacts with water to give methane, so that's not very exciting. Or maybe they are methanogenic microorganisms swimming in this ocean. And so we need definitely a space mission to go to those icy moons and to determine whether there is life here in this ocean. The future, well, the future is bright. This week, NASA announced that they will have a mission being launched in 2026. It's a mission to another moon of Saturn. It's called Titan, and the mission is called Dragonfly. It is extremely exciting because it's a mission specifically to determine whether there is life in this moon. So, as I said, the next 10, 20 years are going to be extremely exciting in the field of astrobiology and trying to determine whether there is life in other parts of our solar system. And not only in the solar system, maybe we have life in other solar systems. Who knows? What we have to do is definitely to explore. Thank you. Thank you.
You know, you can see just another reason why Portugal bursts with pride over their scientific community. I think I burst with pride knowing that there are scientists like Zita out there in the world. We're going to take a 15-minute break, stretch your legs, get a cup of coffee, use the men's room, and then we're going to start promptly. So I know you're a tough group to get back in. It's like herding cats, but let's try to keep it to 15 minutes. Thank you.